Another example, here we have this football player, which is throwing in this ball with the initial velocity of 80 foot per second with this direction, 35 degrees from the horizontal direction. And the question is, what is v dot? What is change in the speed? And also what is rho, the radius of curvature, when time is equal to 1 and also time is equal to 2. I'm going to solve it for one of them, like t is equal to 1, and you can do the other one. So what's happening here, we have this ball, and we are shooting it in that direction with initial velocity of v0 with the angle of theta. So it's going to go up and gradually come down because of gravity, right? After 1 second, let's say the particle is here, and we want to find v dot, and also we want to find the radius of curvature of it. So because we are trying to find the radius of curvature, so if you think about it, we have the radius of the curvature in normal tangential coordinate equations. So it's better to use normal tangential coordinate, right? So let's say at time is equal to 1, the ball is here. In that case, this is going to be my tangential direction, tangent to the path. This is going to be my normal direction, normal to the path toward the center of the path, or the center of curvature. And from the other side, I can find the velocity of this particle using the equations that we had for xy coordinates. Why I need the velocity? Because my goal is finding rho here. We know acceleration in the normal direction is equal to velocity squared divided by rho, right? If I know what is velocity at any point, and if I know what is the acceleration in the normal direction, then I'm going to be able to find rho. Rho is going to be v squared divided by an. So I need to find the velocity at time is equal to 1, and also I need to find what is the normal acceleration at that given time. I would say stop this video here and think about it yourself for 10 minutes, then see the rest of the video. So at time is equal to 1, we have velocity in the x direction. Let's say this is x direction and this is y direction. Velocity in the x direction is equal to velocity in the x direction at the beginning, plus acceleration in the x direction times t, which is 0, because there is no acceleration in the x direction. And velocity in the y direction is going to be v0 in the y direction plus acceleration in the y direction times t. So at t is equal to 1, we are going to have velocity in the x direction as v naught in the x direction, which is v naught cosine of theta. So it's going to be equal to AD times cosine of 35, which is 65.5 foot per second. And the velocity in the y direction is going to be v naught sine of theta, or AD times sine of 35, plus acceleration, which is negative g, times t, which is 1. And if you calculate that, v1 is going to be equal to 13.69 foot per second. So if I draw them here, the velocity in the x direction, we're going to have something for it, and the velocity in the y direction is going to be this number, 30.69. And if I add them together as vectors, if I bring that vy here and add them together, the result, the total velocity, must be in the direction of et. So this is the total velocity, which we know always is going to be in the tangential direction. And the magnitude of the velocity is equal to vx squared plus vy squared, which is going to be 66.5 9 foot per second. So this is the total velocity. I got the total velocity, and if I find acceleration in the normal direction, then I'm going to be able to find rho. But what is the acceleration in the tangent in the normal direction? Because the particle is moving freely in the air, the only acceleration we have is the gravitational acceleration. So the total acceleration, if I show it with a different color, the total acceleration of the particle is going to be g and downward. And acceleration in the normal direction is going to be component of its total acceleration in the normal direction. And acceleration in the tangential direction, or v dot, is going to be the component of g in that direction, because this is the total acceleration, right? So I need to know what is this angle, which is equal to this angle. Let's call it alpha. If I find this alpha, then an is going to be g times cosine of alpha. And how can I find alpha? Alpha is going to be tangent inverse of Vy divided by Vx. So let's write it here. Alpha is equal to tangent inverse of Vx divided by Vy, which is going to be equal to 11.8 degree. And based on what I said, acceleration in the normal direction is going to be the total acceleration times cosine of alpha. So an is going to be equal to g times cosine of alpha, cosine of 11.8. So, and also the question is asking about v dot as well. V dot, we know it is acceleration in the tangential direction. So again, going back to this plot, to this graph, the total acceleration is g downward. The component of this acceleration in the tangential direction, which is the positive of it, is this, is going to be v dot, or at. And the component of g in that direction is going to be g times sine of alpha, but in the negative direction. So at, or v dot, is equal to negative g times sine of alpha, which is going to be equal to negative 6.58 feet per second square. Keep in mind g is equal to 32.2 for US unit. And also, after finding an, I can use this equation to find rho. Rho is going to be equal to velocity squared divided by an. So it's going to be equal to 66.9 squared divided by an, which is 32.2 times cosine of 11.8. And if you put the numbers, this is going to be 142.2 foot. So this is my acceleration. This is radius of curvature. This is acceleration in the tangential direction, or v dot. And this is the total velocity. We can do the same thing for the other part when t is equal to 2.